Look around you. Isn't it astonishing that there is so much variety in day-to-day things? Have you thought what are they fundamentally made up of? Are there few fundamental things that make up everything, or is there no relation between different objects? Earlier civilizations believed that there were 4 or 5 basic building blocks that make everything. They were earth, water, fire, air, and ether. In Hindu civilization, they are called Panchatattva. But obviously, at present we know that there are 118 elements and even more might be found in the future. One of the first clues that these 5 things are not fundamental came from air. Before 1754, it was not known that air is made up of different gases. It was thought to be a fundamental entity. In 1754, Joseph Black wanted to find a cure for kidney stone. He knew that acids could dissolve many things. So he poured acid in a chalky substance and trapped that air which was coming out of it. He poured that air on a burning candle and unexpectedly the candle burnt out. Also, this air was heavier than the normal air. It was evident that this was a different kind of air. Joseph Black had stumbled upon carbon dioxide or CO2. Solids and liquids were known at that time, and air was thought to be another state, but Black found that it was not the case, and air is not one of a kind. There can be other airs, so a name, gas, was given to the third state. In the next 20 to 30 years, other gases were discovered. In 1766, Henry Cavendish, the same person who found the value of gravitational constant, isolated hydrogen. In 1772, Daniel Rutherford found nitrogen. Joseph Priestley, who liked to mess around with experimental setup and ingredients, mostly poured acid on most things, found 9 new gases. They were nitrous air, diminished nitrous air, nitrous vapor, vitriolic air, diphlogisticated air, marine acid air, alkaline air, inflammable air, fluor acid air. He was also looking for accidents. One such accident occurred in 1767. He was living near a brewery. Just above the container of a beer, he saw a haze of carbon dioxide bubbling up from the fermenting brew. He found that if he poured water from one of the glass to another glass over the surface of it, the gas mixed with water. He discovered carbonation, or as we call it, soda water. Somehow this news was heard by the father of chemistry, as we now call him, a Frenchman called Antoine Lavoisier. As we know that the theory of air was changed, air now consisted of various gases. The long-held idea of chemistry regarding fire, water, etc. were also challenged now. One of the theory was phlogiston theory. Now what is a phlogiston theory? According to this theory, ore and phlogiston make a metal. And if we remove phlogiston from the metal, it becomes rust or calx as it was called at that time. But the problem with the theory was that rust weighed more than the metal even though phlogiston was removed from the rust. Lavoisier was puzzled by it. He was a brilliant experimentalist. At one point of time, he had the best personal laboratory in the world. He mixed lead culls with charcoal. He put it in a container and put that in a partially filled glass of water and applied heat to it. He observed that air came out. According to him, calx minus air equal to metal and metal plus air equal to calx. It was opposite to the theory at that time. The whole foundation of chemistry was challenged. Was the normal air involved or some new gas was evolved from it? Priestley came up with the answer. In August 1774, he found that the reddish substance or calx of mercury decomposed into mercury and also released an air, but this air helped the candle to burn. The candle burned and glowed better. He discussed it with Lavoisier and others at the dinner table at Royal Academy of Science in France. Lavoisier recognized that Priestley was onto something. Lavoisier started the experiment while Priestley did other projects in the meantime. Apart from this, Priestley went on to find that this gas could help in breathing. He tried the gas on rats. The rats survived for a longer time period than usual. Then he took that gas on himself. In the beginning it didn't seem any different from the normal air, but after a few moments he felt easy and light. Meanwhile, Lavoisier conducted his own experiments. He announced his findings at the 1775 Easter meeting of Academy of Sciences. He gives it the name oxygen. He doesn't even mention Presley. While it was Presley who discovered the gas, it was Lavoisier who found remarkable conclusions from the gas. Over the next 15 years, he divided elements into metals and non-metals. He showed that air consisted of nitrogen and oxygen, that water is also consisted of hydrogen and oxygen. Fire was not an element, but a process of burning in the presence of oxygen. Even the substance inside the earth were now looked differently. He showed that by stripping away oxygen from ore, we could obtain the metals. So earth, air, fire and water were all now stripped out, and Lavoisier wrote a textbook which listed the first modern list of elements. Obviously, there were some elements which are later found not to be the elements but compounds. It was the start of a revolution in chemistry. One of the chemists who played a big role in this revolution was Humphrey Davy. Humphrey Davy dropped at 16 from the school after his father's death, but he continued to learn on by himself. He tackled with one theory of Lavoisier about heat. According to Lavoisier, heat was a material substance called calorie, but Davy thought it was because of the motion of particles. Davy used to test the various gases on himself, like carbon monoxide, carbon dioxide, laughing gas, etc. He discovered that nitrous oxide had a tinkling sensation. As the news spread, James Watt, the king's own doctor, tried it. He would record the feelings of various people. At the time, Volta invented voltaic cell. Two British scientists used voltaic cell to split water. It burnt with a popping sound and oxygen increased the flame. Davy wanted to find about how the current split it. He thought, if electricity broke the bonds, is it possible that it is the same force that holds them together? After the invention of electrolysis and battery, many new elements were discovered.